Welcome. This video introduces pointers. So a pointer is an amazingly powerful, somewhat dangerous, potentially confusing tool, but at its heart, really all a pointer is a variable that stores a memory address. So up till now, we've always thought of variables as storing values. Right? I've got this variable score, and somewhere in memory, it's stored, and it's got the value 12.5. Well, a pointer is the same idea. We could have a pointer called p, and somewhere in memory it stores a value. But what a pointer always stores is not kind of its own value, but it actually stores the address of another piece of information. So here, p is storing 0001, which would signify that it's storing the address of this piece of information. Basically, it has the address where score is. Now, the way we declare a pointer is with the star symbol. If you're doing a declaration, and we've actually got two different meanings for the star symbol, slightly different, both related to pointers, but there's two slightly different ways to use it. But if you're declaring a variable, like int star x, what that says is x is a pointer to an integer. X can point to, it stores the address of an integer variable. A pointer always points to a particular type of information. Here y points to a double. So y would store a memory address for a floating point value, a floating point variable. The location of the star doesn't really matter, and you'll see it kind of both ways. Our book uses this version. I like the top one, and I'll be using this mostly in the slides because it makes it clear that the star is really part of the type, not of the name. Right? The name of this variable is x, and its type is pointer to integer. This one makes it look like the name is star x, and the type is int. So when we create a pointer, p is a pointer to an integer. Like anything else, it starts with just whatever's randomly in memory at that location. Which, if we're pointing off to this location in memory and I go try and do something with it, we're going to be in real trouble. So to give a pointer an initial value, we have to use the address of operator, the ampersand. So kind of like the star, this has multiple meanings. In C++, this means reference, if we're doing a parameter, or we can have a reference variable. But if we put this in front of the name of a variable like ampersand x, what it says is, give me the memory address of x. So if memory looked like this right now, and we asked for, give me ampersand x, we'd get 1, because that's the memory address where x currently is. So we can use this to set the address, set a pointer to store the address of a particular variable. So x is here, it's got a value of 100, get the address of x, which will be 1, and store that in p, which makes sense because p is a pointer to an integer. It wants to store the address 0001 of this other variable where we can find an integer. We can take pointers, and just like any other data, we can copy them. So I could have this int pointer q and assign it the same value that p has, basically copy the location. And so now both p and q point back to location 0001 to x. We can, if you want, you can compare them using equals or less than or greater than, but what you'll be comparing is memory addresses, which is usually not what you want. You might want to compare two pointers to see if they point to the same thing, but usually less than and greater than don't make much sense. Most of the time, what we use pointers to do is to access the values they point to. And we do that with the star symbol. So when it's used outside of declaring a variable, it's called the dereference operator. So star p by itself says, go take p, 0001, take the value it stores, and go to that location. Go to here. And once we've done that, so we can do that to change a variable. So if I have this code, I've set up P and X, and I'm right here, and I'm about to run this, this says, go to P, go get what P has, 0001, go to that location, the star says dereference that address, go to that location, and set it to be 200. So we run that line of code, and we actually change X. If then I want to print out what P points to, print out, go take the address that's stored in P, dereference it, so go to that address, get the 200, and print that out. And then if I print out X, I'd print out 200 because it's actually been changed. P pointed to X, so when we changed the value that P pointed to, we really changed X. Star P is basically just another name for X at this point because P points to X. We can have a pointer to a pointer. So Q points to a pointer to an integer. A little bit confusing, but basically Q wants to store the address 0002 of a pointer that has the address of our integer. And so if I print out, hey, what's in Q, I'll get the address where P is. If I print out, go to the address Q has, so start with 002, go to that address and print out what you find there. That would be 0001. If I dereference it twice, so take what Q has, 002, dereference it once, so go to that address, okay. Go to that address, so 0001, go to that address, that would take me here. That value is 200. We can have a null pointer. So if we want to have a pointer that points to nothing, basically we have to set it to be 0. And rather than just putting 0 in our code, we use a keyword. In C you use the keyword null, and that often works in C++ compilers as well. Technically though, in C++ you're either supposed to use 0, or in more modern versions of the language, you use the keyword null pointer. So if you want to make a pointer that points to nothing, and you want to do it safely instead of pointing to some random piece of memory, you set your pointer to be null or 0 or null pointer. One word about pointers in Qt Creator is that to try and be helpful, the debugger is always going to dereference pointers. So if I have I that stores 5 and P points to I and Q points to P because it's a pointer to a pointer, they're all going to show the value that they point to, not the memory address. So if you really want to see, if you're using the debugger and you really want to see the raw addresses, you have to right click on P and change the local display format and say, please show me the raw pointer. And then it will actually show you the memory address that it's pointing to, what it really stores. And then you can crack that open and look at the value it points to. And if you've got a 2-level one, then you'd have to set P to be a raw pointer, or Q to be a raw pointer, and then go to star Q and say, you know what, even this is a raw pointer. And so you'd have to do that step twice. And that way you'd be able to see that Q points to this memory address, which is where P is, which points to this memory address, which is where I is. And remember, anytime you see one of these, we've seen this with arrays, anytime you see one of those 0x, something, 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 that's a hexadecimal memory address. And so then you know you're looking at a pointer or an array. We can work with pointers just like any other data type. So they can be parameters to a function. This is actually how C does pass by reference. C++ added this idea of reference variables and being able to pass by reference. C does not have that. So in C, if you want to do something equivalent to passing by reference, you pass in a pointer. And you do that by saying, okay, I'm going to do double variable C style, and I'm going to pass in the address of my variable. And so it takes in the address, stores that into this pointer, and then it modifies that variable using the pointer. All right, so we dereference X and say go to that memory location, multiply it by 2, store the answer back into the address that X is storing, and that would actually modify the original variable. The C++ style, a little easier, right, because we don't have to deal with the dereferencing, but does the same job. If I start with 10 and I call double variable and I pass into the C++ version, that takes num as a reference, calls it x, and doubles it, it becomes 20. Then I pass into the C version, where we pass in the address and work with the address as a raw pointer, it doubles again. Right? So the same effect, just different ways of doing it. And we can even return the address of a function. So this takes in two variables, the address of x and the address of y, and compares their values. So we dereference them using that star symbol. And whichever one has the smaller value, we return that one's address. A little bit of a silly function, but we're going to see a very important use for this idea of returning the memory address of something in the next video.